Hey everyone, and in this video we are going to be talking about calculations in gas volumes. Now, calculations in gas volume is a very important part of chemistry examinations and for you to understand chemistry properly. So, and today we are going to be talking about the summary of the gas laws. So, we are giving you a summary of your Charles, Boyce, John Dalton's, Gleduzownë, Grams, and all those gas laws. We're giving a summary of the four principles on which they are all based. Then we'll be talking about calculations, and in this calculation section we will be applying calculations involving gas laws and be using it to find out the relative molecular mass and also the volume of a reaction. So now basically let's delve into the matter. So let's start from the summary of gas laws. Basically, well, I've given a summary of gas laws in that the gas laws can be summarized into four basic principles, which is the first one is that at STP, all volume of all gas at STP is 22.4 dm3. So that states that that is the first law, which states that it's just like a continuation of Avogadro's law, but it states that there's a reference that STP is the standard reference from which all we calculate the relative volume of all gases. So and that you can, if you know the volume at one temperature, you can calculate the volume at STP because STP is known. So and vice versa, if you know the volume at STP, you can calculate the volume at another temperature or pressure. So now also the second one we have is that the volume of any gas in a mixture of gases is equal to the volume of the mixture of gases. So that means if you have a mixture of gas A, B, and C, and that mixture occupies 5 dm cube of volume. So that means the volume of any of those gases, of only gas A, will also be 5 dm cube because those gases mix uniformly, so they occupy every space. So that's why the volume of any gas in a mixture is equal to the volume of the mixture. That's the second law. Then we have the Avogadro's law, which is the third law of the third general law of gas laws, which says that equal volume of all gases at the same temperature and pressure contain the same number of molecules. So what that means is that if you have 2 centimeter cube of oxygen and 2 centimeter cube of hydrogen at the same temperature and pressure, they will contain the same molecules. So if this one contains 2 molecules, this one also contains 2 molecules. That's what Avogadro's law simply means. Then lastly, they have the law of molar volume, which says that the molar volume, or the volume of 1 mole of any gas at STP, is equal to 22.4 dm cube, or 22,400 centimeter cube. So let's move on to calculations under gas laws. So the first calculation I'm doing is calculation to determine the volume of gas. So the question states the volume of oxygen at 12 degrees Celsius and 7.5 millimeter mercury. So the let's call T1 is 12 degrees Celsius. So you have to convert to Kelvin, which will be 12 degrees plus 273. That's 12 plus 273. That will be 285. Yes, I will know that. Then the pressure is 745 millimeter mercury. That's P1 is equal to 745 millimeter mercury. So now the next says which could be calculate the volume of oxygen at 12 degrees Celsius and 745 millimeter mercury, which will be obtained by heating 5 grams of potassium trioxochlorate. So the mass of potassium is 39, the mass of chlorine is 35.5, the mass of oxygen is 16, and the molar volume of any gas at STP is 22.5 dm cube. So moving on to the solution, we have something like this. So let's represent the equation of the reaction. We have KClO3, potassium trioxochlorate, chlorate 5 will decompose to form potassium chloride, that's KCl, plus O plus oxygen. So basically this is the equation of the reaction. So and then the potassium trioxochlorate is a solid. The potassium chloride is also a solid, and then the oxygen is a gas. So if we balance the reaction, you can use any of the methods I taught you in the previous episodes of this crash course in chemistry. So you can use the try and error method, or you can use the coefficient method. But let's move on with the that's already been done here. That's 2 moles of KClO3 we give 2 moles of KCl plus O2 plus 3 moles of oxygen. So basically now we can now use this ratio. So if 2 moles of KClO3 will give 3 moles of O2. Now they now said now let's take value of standard temperature and pressure. T2 at STP, the temperature is 273 Kelvin. At STP, the pressure is 760 millimeters of mercury. Then at STP again, the volume is what? So that will be 22.4 dm cube. So then the volume at the given temperature and pressure for this question, we don't know it, so but that's the unknown. That's what we're looking for now. So moving on, let's see what we can do. So now the molar mass of KClO3 is 122.5. So that means if in the question we have 5 grams of KClO3. So that means the moles, the number of moles is mass over molar mass. That will be the mole of KClO3 will be mass, which is 5 grams over the molar mass, which is 122.5 grams. So that was the mole of KClO3. Now in this reaction, 2 moles of KClO3 will give 3 moles of O2. So that means the relative number of moles of O2 will be 3 out of 2, 3 over 2 times. So the number of moles of oxygen produced at in any times of the reaction, because this chemical equation is balanced and it will be constant. So for at any conditions, the relative number of moles of oxygen to KClO3, potassium trioxochlorate, will be 3:2. So that means if the moles of KClO3 is 5 over 122.5, so the relative moles of oxygen will also be 3/2 times 5 over 122.5. So that's just basically a proportion when you take the proportion of the moles. So now the mole ratio is 2:3. So this is 2:3. Then we now have that okay. So that is 15 over 245 moles. So we have 15 over 245 moles of oxygen produced. So at that same conditions given for the question, so that means the volume at STP produced will be if 15 over 245 times the 22.4 dm cube times 22.4, that will be 1.37 dm cube. So now basically what that means is that that's the ratio of the volume of that actual oxygen produced. So now we are not done yet. We've not gotten the final volume, because now we are going to convert to the volume at our given temperature and pressure. So we'll make use of the general gas equation, which says that P1 over T1 is equal to P2 over T2. So making V2 the subject, we have V2 is equal to P1 T2 over P2 T1. So when we substitute our values, we have V2 will be P1 is so we are looking for P2, right? Sorry, rather we are looking for let's change our values. Let's call this one let's one be T2 P2 V2 T1 P1 V1. So we are looking for V2, right? So V2 will be equal to P1 that's 760 times 22.4 times T2 is 285 Kelvin, 285 divided by P2 is 745 millimeter mercury. Then T1 is 273 Kelvin. So if we solve these equations, we will get our volume as 1.46 dm cube. 1.46 dm cube. You can also try the question on your own to cross-check the values given. So that is how to use the molar volume and gas laws to get the volume at a particular conditions of reaction. Then lastly, for this video, let's talk about using it to calculate the relative molecular mass. So now the relative molecular mass, let me give this question. If 350 centimeter cube of a certain gas were found to weigh 1 gram at STP, what is the molar mass of the gas? So if 350 centimeter cube weighs 1 gram, so what's the molar mass? So we know that the molar mass at STP, the molar mass will weigh 1 mole will weigh 22.4 dm cube. So 1 mole will weigh 22.4. So now they said how many moles will weigh 30 cm cube, right? Let me take that. 350 cm cube. So let's call the number of moles x, and we'll just cross multiply. We'll say x is equals to 350 times 1 mole over. Now the when we convert 22.4 into cm cube, that will be 22,400 cm cube. So when we divide both sides, we have the number of moles. Okay, sorry, 350 centimeter cube weighs 1 gram. I misinterpreted the question. So 350 weighs 1 gram. So that means this 350 weighs 1 gram. So what will be the weight? What will be the weight of let this be x. So what will be the weight of the molar of the gas? So that weight is also known as the molar mass, and it is equal to 22.4. So let's change the equation. That will be 1 times 22.4. 1 times 22.4 divided by 350. So at the end of the day, when we cut everything down, we'll get 64 grams. That means the mass of the mass or the weight of that gas is 64 grams. So in summary, we've talked about summary of gas laws, and we've also talked about calculation involving gas laws. So thank you for watching.